Okay, so the goal of this video is to look at transformations when you have something like this, like example 16, theta minus 30. And remember, like there's no left-right direction. There's no up-down direction when you're graphing polars. It's simply an angle or a rotational direction. So when I think about theta minus 30, I kind of want to associate it with thinking about it like if I'm solving algebraically and I said, like x minus 5 times x plus 6, and I said solve, it equals to 0. You would look at that parenthesis and you would try to find its 0. And its 0 would be when x was 5, or this 0 would be when x is negative 6. So similar to that concept is like finding the 0 of the rotation. And so like 30 degrees, 30 degrees, when theta is equal to 30 degrees, that's like the 0 of that graph. So if I think about rotating 30 degrees, finding where is 30 degrees, which is right here. So this rotation of 30 degrees in a counterclockwise direction sort of is going to be the new x-axis. So like this right here, rotated 30 degrees, I could think of that as the new x-axis. And then your 90 degrees rotated, so like you still get like that perpendicular. So a lot of times when I see rotations, I like to draw in like, okay, here's where the new x and y axes markings would go. And I'm still thinking about this -4 plus cosine. So if this were just normal r equals -4 plus cosine of, I'll call it, let's say alpha. Since this value is larger as an absolute value than this, it's going to be a limison without a loop. So I could think about r and theta, or in this case alpha, and I like to do like 0, 90, 180, 270, and then it would be back to 360. And so here for cosine of this alpha is 1, and then 1 plus -4 is -3. So on this like new line, which translated to like the 30-degree line, I would go -3. So then I, let me go to purple here, and maybe go just a little bit thicker. There we go. So I go -3. So 1, 2, 3. So I'd be right there. Now, even though it's the quote-unquote 0, I still have to label appropriately to the graph. So it's going to be -3, 30 degrees. So it's no longer a true quadrantal value because it's been rotated. Now, the 90 would have been where cosine does nothing. So then I would just have gotten -4. But that 90 now got shifted to 120. So it's at the 120 marking, I go -4, which is great because even though 120 is in that direction, negative would go 1, 2, 3, 4. So we're right here. I guess I could go back and change it to purple later. And then 180 would have been -1. And then we get a value of -5. But the 180 is switching to like the 210 marking, which is along here. But then going back -5, 1, 2, 3, 4, 5, puts you out here at -5, -210. This one right here I should have written down was -4, 90 degrees. And then our last one, 270, cosine does nothing. So we're left at -4. Remember, the 270 got switched to 30 degrees, so it's at the 300 mark. So again, looking at the 300 mark and then going back to -4, 1, 2, 3, 4, which is right there. So now I'll go back to purple and I'll go ahead and sketch that. And remember, even with the rotation, the graph itself goes in a counterclockwise direction. So starting here, this point, and then hitting over to the 90 degrees or where the new 90 was. And so, it's a limison that flattens out a bit. And again, it should be a little bit flatter at the -330 side. Maybe I'll go ahead and do this in a yellow as well. And now just a little bit thicker, just to really see that graph. So a little bit flatter here, going in that direction. So it has been rotated, and I will go ahead and star the start. Now here's the thing. The start is not where we put our first point. The start is still 0. So technically, I have to put the star right there at the 0 degrees, because at 0, I'd get a negative radius. So just be really careful about that. But then it's been rotated, 30 degrees in a counterclockwise direction. Okay. Now there's another rotation on the more practice. So if you look at I should say mixed practice. So this 3 plus 3 cosine of theta minus 30. Again, it's a 30-degree rotation, and it's 30 degrees in a counterclockwise direction. So just based on what we did, like I know that I could make that the 30-degree mark, that the 30-degree mark, and the same thing here, 30 degrees. So I've got that rotated. The nice, rotation there. Now this will be a cardioid, 3 plus 3. So getting a table of values is certainly a good thing to do. And maybe call it R and alpha just to start with, just till we do the translation. So 0, 90, 180, 270. And then we start with cosine, just thinking about what if this was R equals 3 plus 3, just cosine of that angle. So cosine is of 0 is 1. So 1 times 3 is 3. 3 plus 3 is 6. Remember, instead of 0, we're at the, quote unquote 30 mark. So 1, 2, 3, 4, 5, 6. So 6, 30. And then at 90 degrees, cosine does nothing, so we're just at the 3. But remember, that got translated 30 degrees, so that's really at 120. Because when you put 120 in there, 120 minus 30 would give you the 90. So the 120 marking, 1, 2, 3 is right there. So that's 3, 120 degrees. 180, you get a negative 1, and then that basically gives you your equilibrium, but that's happening at 210. So even though it's still at the origin, so I can't really tell what its value is, I still need to label it as 0, 210, because that's what would fit this equation. And our last one, the 270, would go back to 3, because cosine of 270 does nothing, but that 270 is really 300. So 1, 2, 3. So we're sitting right there at 3, 300. So now we'll draw our cardioid, and I'll make it a little bit thicker here, so it hopefully sticks out. And it doesn't. I mean, like, I know 0 starts down here, but when we did our cardioid, we know like the farthest point would have been there. There we go. Just make it a little bit thicker. There we go. So kind of like thinking about circular, coming in to the point, and then going out and kind of rounding that out like that. Okay. And it's still going in a counterclockwise direction. So I should draw arrows going in that direction. And again, the start is still 0 degrees. So even though I didn't label it, I'm still putting that star right there. Okay, I think I've got one more rotation in the mixed practice. Yeah, secant of theta plus 15. So now plus 15, now that's a 15 degree rotation in the opposite direction, because negative 15 would 0 it, right? So I know that my rotation is negative 15 degrees, or it's a clockwise 15. So then that's just one of these tick marks. So let me go ahead and pick that. There we go. So 15 degrees one way, 15 degrees the other. Oops, the other axis. So like that's that rotation of 15 degrees. Now the thing is, 6 secant, if this would have said R equals just 6 secant of theta or alpha or whatever, that's a vertical line. And that vertical line is 6 units along the x. It's like saying it's x equals 6. So normally what I've done, I've gone 1, 2, 3, 4, 5, 6, and just drawn a vertical line. But what I'm going to do is I'm going to take that distance of 6, and that becomes rotated that 15 degrees. So I'm going to count 1, 2, 3, 4, 5, 6. So it's that one right there. So and I want to make it parallel to the new y-axis. If I draw that here, maybe I should probably make it just a little bit thicker. I just like to be able to see that. So there's my quote unquote vertical line that's been translated, or I should say, been rotated 15 degrees. So there's not really any markings I need to put there. You know, I mean, if you want to put 6 comma negative 15 degrees, because that's true. You know, but then again, I want to make sure I'm maintaining that distance here. So 1, 2, 3, 4, 5, 6. So that gives me that that rotation. So like, you know, there's obviously more practice ones in the homework. So take a look at those, give those a try. I think it's very helpful. I do think it's very, very helpful to draw in the new axes that's been rotated. Oh, and the last thing I forgot is to start the start. It's still 0 degrees. And so remember, 0 degrees is wherever it crosses that the x-axis. So at 0, I'm sitting right there. Okay. Excellent. Very good.